Good morning, good afternoon, and good evening. I'm Ngawang Dendu from ADBI. It's an honor for me to welcome Professor Yuta Toyama from School of Political Science and Economics. Professor Yuta Toyama is an associate professor of economics in the School of Political Science and Economics at Waseda University. He received his PhD in economics from Northwestern University, and his research lies in the intersection of empirical I/O and energy and environmental economics. Today, Professor Yuta Toyama will present on designing nonlinear electricity pricing with misperception, evidence from free electricity flow. It's an honor to have you. Floor is yours.
Right. Thank you very much for having me here. I'm Yuta Toyama from Waseda University. And this is a joint work with Gawar, who was my colleague, and he was joined maybe by a few years ago. So, can you just describe how it is? It's like, oh, sorry. I think we have to mute there. I think it should fix the problem now. Okay, put it in.
Okay,
Hi.
so there'll be no.
I think okay. Okay, oh, yeah. It fixed. Thanks very much. Okay. So yes, Gawar used to be my colleague at Waseda, and he joined, ADBI years ago, and the usual disclaimer applies to our work. And so in this paper, we study nonlinear pricing in the context of the electricity market. So in particular, we analyze free electricity policy conducted in Japan, and this policy is something about energy subsidy for households. Okay, so let me start with the broad motivation of the paper. So as we all know, financial incentives are nonlinear in many different settings, including progressive taxation on income tax and the quantity discount in supermarket, and also the pricing in the utility service. And especially in the context of utility service, we observe so-called increasing block tariff. So this figure shows one such example at TEPCO. So up to 120 kilowatt-hour per month, the unit price of electricity consumption is 20 Japanese yen. But above 120, you have to pay 26. And for the portion above 300 kilowatt-hour, you have to pay the highest price, that is 30 Japanese yen. So we can see from here that the unit price changes discontinuously at these regressions. And this type of tariff structure is widely used in many countries, especially in the electricity service. And also the pricing of utility service is highly policy relevant issue because it will lead to public utility regulation, environmental taxation, and energy subsidy. And energy subsidy is a key focus of our paper in application. So you might think energy subsidy is just policy tool adapted in developing countries, which is partially true. So looking at some developing countries, including India, South Africa, and Thailand, the government offers energy subsidy. So one example from India is that it offers 200 unit free electricity per month for households in Delhi. Okay? And also, looking at developed countries, we see energy subsidy, especially during the Europe's energy crisis following the Russia-Ukraine war. So in Germany or Austria, the government introduced price cap. That is, the price is capped up to certain consumption limit. And above that, households have to pay the regular price. Okay. So from here, we can see that this energy subsidy is pretty common policy tools in many settings. So now let's think about the pros and cons of such nonlinear pricing. So one of the pros of this pricing scheme is that it can address distribution concerns in the sense that it offers low price for low income consumers who are consuming less amount of electricity. But if you are rich and so that you will consume more electricity, then you will face higher price, which means that you will be incentivized to reduce electricity. Okay? So that's one of the pros. But there are some cons from the inefficiency perspective. So one thing is that, based on their textbook style argument, the pricing set to the marginal cost is the first. And also there are another source of inefficiency that is known as misperception. So in the context of such nonlinear and complex pricing schedule, consumers may not correctly consider the pricing schedule in their optimization. And this, phenomenon has been documented in the previous literature, including Ito as well as Schaeffer, those papers. So given these motivations, we're answering the following research questions. First, how should we design the pricing schedules when consumers may have a misperception about the pricing schedule? And then, what are the welfare and distributional implications of nonlinear pricing under such setting? And we answer these questions in the context of residential electricity service. So we have, two contributions from the methodological perspective as well as in application. So from the methodological perspective, we construct an empirical framework for electricity demand that incorporates misperceptions. And then we apply this framework to analyze the free electricity policy in Bhutan. So let me briefly talk about this method and application first, and then we move to the main part of my presentation. So methodologically speaking, we take a structural econometric approach to analyze nonlinear electricity pricing. So we start with constructing a model of electricity demand that incorporates heterogeneous misperceptions. So I will be more specific about what kind of misperception that we're going to think about in the paper. And then based on this model, we're going to think about the identification and estimation strategy for the underlying structural parameters, namely the distribution of misperception types as well as electricity demand. And then using the estimated model, we conduct simulation analysis to think about the impact of alternative pricing schedules and also discuss welfare implications. And this is a key novelty of our paper compared to the previous works. And then as an application, we analyze free electricity policy in Bhutan. And I'll give you more details about this policy later, but the basic content of this policy is as follows. So in October 2013, the Bhutanese government introduced this policy under which the first 100 kilowatt-hour of electricity consumption per month becomes free in rural regions. And to analyze this policy, we use administrative billing data from the utility company. And from the descriptive analysis, we find that electricity consumption indeed increased thanks to this free electricity policy. And at the same time, we find a distinctive bunching just below 100 kilowatt-hour after the introduction of policy. And then we move to a structural analysis to think about the welfare effects of the subsidy. And here are the main results. So first, regarding misperceptions, we find that most consumers are average biased, which is in line with the previous finding in the literature. And secondly, we analyze the welfare effects of free electricity policy, which turned out to be that the policy was inefficient. And then, as an alternative, we simulate the optimal nonlinear pricing that maximizes utilitarian welfare. And such pricing scheme predicts a flatter price schedule. That is, there is not that much of like a step function. But it produces only limited average gains, and it actually has worse distributional implications. That is, it creates both winners and losers under such, hypothetical optimal pricing scheme. And then lastly, we think about the optimal pricing schedule that considers inequality aversion in terms of welfare, and such pricing predicts zero price in the first year, which is pretty similar to what we have in reality under free electricity policy. So I'll skip directly to literature. So let me first talk about the background of this policy and then introduce the data and then move to model-based analysis. So Bhutan is a small Himalayan nation in South Asia, and this is a country where Gabon has grown up. And it has less than 1 million population, or around 160K households in 2017. And by the way, these two pictures are photos that I took when I visited almost 2 years ago. So it's pretty like a mountainous country. So here I want to talk a little bit about the demand and supply structure in electricity in Bhutan. So regarding the demand side, electrification rate is pretty high. So even in 2012, that is almost like 10 years ago, the electrification rate was 87% in rural, and it's almost perfect in urban regions. And people use electricity for lighting as well as essential electrical appliances, including rice cookers, as well as like charging mobile phones. And regarding the supply structure, the utility company is completely regulated. That is, their tariff needs to be approved by the government. And Bhutan mostly relies on hydropower plants for generating electricity. And interestingly, there is no fossil fuel power plants in Bhutan. So then you might be wondering how to make a balance between supply and demand, which is crucial in electricity service. So Bhutan relies on trading with India. That is, during the summer season, when hydropower plants produces a lot of electricity, they export the surplus or the remaining of electricity to India, and this accounts for like almost 12% of GDP. So which is an important source of revenue from the foreign country, and also. But during the winter season, when the rivers got frozen so that the generation goes down, Bhutan imports electricity from India. So that's the demand and supply structure. So now here's a key part of our paper. There is tariff structure and fleet electricity policy. So let me show you the price schedule before subsidy first. So on this right panel, on the left panel, we have this like a unit price schedule. So we have like two thresholds, namely 100 and 300. So the y-axis is like the unit of the y-axis is neutron, which is roughly speaking 1 Japanese yen or 1 cent in US dollars. And then from October 2013, the government introduced the electricity policy. Under this policy, rural households get first 100 kilowatt hour of electricity for free. So we can see the pricing schedule after this policy in this right panel. So you can see that urban households have to pay some like positive price up to 100, But rural households, these like red dashed ones, doesn't have to pay at all up to 100. But for the portion above 100, they have to pay the same price. So in other words, rural households can get the first 100 kilowatt-hour of electricity for free. So we did an interview with like some government officials when we visited Bhutan 2 years ago, and they mentioned that one of the purpose was to reduce fire consumption as well as to mitigate like migration from rural to urban areas.
Can I ask clarification?
Yeah.
Okay, one, you said that during winter time when the river is frozen, Bhutan is imported from electricity from India.
Yeah.
In aggregate, is Bhutan a net exporter or a net importer? And if it is a net exporter of electricity, how big is it relative to the total electricity production of the country?
I see. I think it's net exporter, and I
Is
think
it large net exporter or is it small?
Net exporter.
Right.
Yeah, we export more than we import. The import is basically
It's not.
the river decreases, so the production capacity also declines. But then, I think most of
So in terms of the total
yeah, we export more.
Yeah, in terms of the total consumption, how large is this net export?
I think substantially large. Substantially, yes.
Yeah, I think so. The question is about the block pricing.
okay.
So from the block pricing, if we look at the average demand of the electricity consumption, where does it lie? Is it lying in between 0 to 100, 100 to 300, or over 300?
So that's gonna be in the next slide. So like
So-
in rural area, right, the median and average consumption is below 100. But for urban consumers, they're in the second tier. That is like median is 160 and average is 180.
So how many percent consumes over 300?
Or 100.
Over 300.
Over 300. How many percent?
I don't exactly remember, but it's quite small.
And mostly urban.
And I have Instagram and I can show you later. Yeah.
Thank you.
Okay, good. Okay, so yeah, I was talking here. Okay, so here's the data. So we use administrative data from that we obtained from Bhutan Power Corporation, or to be more precise, Nugawan had made a huge effort to get this wonderful data from the utility company in Bhutan. So all the credit should go to him. Anyway, so the data is the map and household level count data that covers from 2012 to 18. And we can track down for each consumer. We observe the consumption as well as bill amount, and we can see whether consumers are in rural or urban, as well as the district that consumers is belonging. And there is already talked about name statistics. So urban consumers are larger in terms of the consumption size, and rural are relatively small. So we first show you some descriptive analysis to see what's going on in a relatively simple framework. So the first analysis is to estimate the free electricity policy by matching different data. So that is, we have some policy variation. That is, this electricity policy was only introduced in rural area, but urban consumers still have to pay their first 100 kilowatt-hour. But obviously, these two consumers are quite different in terms of consumption size, even before the policy introduction. So we did some matching analysis. That is, we made a match sample in terms of the consumption pattern in 2012, which is way before the policy introduction. And then we did different data to see the impact of this policy change. And here's the key results. So this red dash line is the timing of the policy introduction. And looking at the the post-policy period, the electricity consumption increased by almost 5 to 7%. Although we don't see that much impact, just after the introduction of the policy. So this suggests that the consumption indeed increased thanks to this free electricity policy.
That's the reduction in consumption in 2 years. That's 24 months, right?
Yes, so we focused on like the relative short time period because the tariff schedule often changes. Like there was like a revision on the tariff schedule in 2015 January. So which is why we've only focused on the period up to 2014 December, but we can extend the analysis.
Person stating a question.
No, that's
I think he's asking why the decrease in the
after the
consumption
3
on month 24.
Month 24.
Yes, that's 2 months after the introduction of subsidy.
Oh, I see.
Yeah.
So that was 3 years. Okay.
I think it was because they were trying to adjust. That's my guess. Because they had this 100, so people wanted to be below 100. So maybe they were not sure initially.
Then
So they were like trying to see how many valves, how many things. And then once they realized, then they could push out. And that's my feeling.
Oh, I see. Yes.
I see. Okay. That's a nice.
I see. Okay, and this figure is one of the punchlines of our descriptive analysis. So we see the distribution of monthly consumption in these both panels. So this is rural before subsidy, and this is urban before subsidy. And this panel B is rural after subsidy, in which we find this striking bunching just below 100. And we don't see such bunching in other panels. So then,
Just there's also one thing that we should also take into account because around 2015, 16, or after the subsidy time, economically we grew a lot. We became much richer than what we were like before 2010. Right? Even in the urban areas, we used to use LPG, but then there was lots of influx of panel, the electric panel cooking stuff. So many families actually use that panel. In my house also we started using panel. That's one thing. That's why I thought like urban consumption would also increase, not because of the subsidy effect, but because of the economy. And also, we used to use lots of firewood for heating the house. Even in 2010, 2005, 6, we used to use lots of bukari. But then, of late, because it's getting very expensive to buy wood, so we are using electric heater and also sophisticated electric heaters that we have been buying. So somehow, my thinking is that the urban consumption should also spike.
I see.
Yeah, but this is for subsidy, so there's no subsidy for urban, so that's why we don't see.
I think I said it more.
easy control of all those factors that Bill mentioned.
Yeah, I thought like the consumption in urban area should also increase, right?
Yes.
Not because of the subsidy effect.
Right. But so this is just the descriptive stats of the consumption. Actually, we don't see that much increase in urban, both at the medium as well as me.
Yeah, that's what.
Yeah, we see rather observe some
There's-
increase
yeah.
in rural.
Yeah.
So
Because because like in Thimphu, I have many friends, many families in my house also. Like everything has become so electrified. We have
Also many houses.
yeah, almost everybody.
You have also many houses.
So I was thinking that the consumption should have increased, but it didn't. Anyway, this is the
yeah. But perhaps we can look at the data by district. Maybe just looking at Thimphu, we might observe more like a huge spike in consumption. Yeah, that's worth to try. But for the This main analysis today, actually, I'm gonna only use very short time window, to mitigate the concern regarding the economic growth, unrelated policy change. Okay. So yes, so I was talking in here. So in here we applied so-called the batching estimator as in Chetty et al. To quantify this excess mass as well as small missing masses around this 100. So these like red points are observed mass, and these blue curves are polynomial fit. So again, we see this excess mass just below 100, but also we observe a small missing masses around above 100, which is in here. And also one implication of this figure is that there are consumers who do not use all of their allowance, even though they are free to use. So this suggests that, there might be some taxation in electricity consumption. That is, because of appliances they have, they may not be able to use all their consumption. Well, they don't have. Okay. So far, we already found some interesting data pattern about the effects of this policy. So one thing is that, it increased the consumption by 5 to 7% on average. And also, rural consumers do not necessarily consume all of their allowance. And then we also find a bunching below as well as small missing mass above 100 after the policy introduction. So then, for the next step, we might want a bit more talk about these things. So one thing is heterogeneous effects across households. And also we want to talk about the welfare implication of the policy. That is whether this policy was to try and implement. So to answer these questions, we're going to take a structure analysis, that is model-based analysis, to think about the welfare effects as well as policy selections. So now we move to a model section. So we start with the following consumer preference or utility function, which depends on electricity consumption C as well as numerator or the expenditure for goods other than electricity consumption. And we assume quasi-linear utility because the share of electricity expenditure is pretty small in Bhutan setting. And we have some preference parameters like alpha, lambda, and gamma. And these are we're gonna estimate later using that. So that's a utility function. And given this utility function, we're going to think about the optimization problems for different types of perceptions. The first type of consumer is called marginal price type consumers, or just the rational or regular consumers. So these consumers have a correct understanding of the pricing schedule. So and we can write down the budget set for these consumers in this figure, which we can see kinks at this 100 as well as 300. So the reason why we have this kink is that the unit price changes discontinuously at 100 and 300. So that's what we call marginal price time. And second type of consumer is what we call average price time. So this is a little bit tricky, so I might gonna skip a little bit of details, but basically these consumers treat the average price as if the marginal price. So in here, this average price is basically the ratio of the expenditure to consumption. So perhaps the next figure might be.
Can I ask you just because of that from the time of I've been thinking this. That key point that you're talking about, let's say my electricity consumption is 100 102 or 105, would the electricity company actually come and collect for that 2 units? Because it's too small. The cost of collecting for 2 or 5 units is too high, or the company BPC has been saying, okay, I'm like, forget up to 10 units, but if it's crossed, then we'll go and collect that. Have they been saying, or like they actually come to collect even if it is 1 unit or 2 unit more?
I think yeah, they regularly visit each household to check the meter and then collect.
Because if I consume, let's say, 2 units more than 100, how much would it cost?
Well, I think in our data set to address that kind of concern, we just removed all consumptions below 5.
You mean like in the data you said like below 10?
Below 10, yeah, that's right. 10 kilowatt hours.
Yeah, we don't use those observations. Yeah. Okay, so yeah, I was talking about this average price type. So here's the difference between marginal price and average price. So this blue one is the marginal price or the actual unit price that consumers have to pay. And this red curve is the average price, which is the ratio of expenditure to consumption. So we can see that this average price and marginal price are the same in the first year, but it starts to diverge in the second and third year because the average price is lower than the marginal price in the second and third year. Okay. And also this like average price is smooth at this threshold, but this like marginal price or the actual price changes discontinuously at these thresholds. So that's the average price. So and this consumer treats this average price as if the marginal price in their consumption decision. And the last type of consumer is called confused type. So these consumers think that the marginal price of the last unit applies to the entire consumption. So meaning that, let's say my consumption is like about 100, and I will face the higher unit price at the margin, and then I mistakenly believe that this higher unit price will be applied to the entire consumption, including 100, which is obviously misconception. And under such perception, the budget set has noticed at the thresholds, namely 100 as well as 300. So there is some like jumps at 100, 300 in the budget set. So these are the 3 types of consumers that we're going to think about. So, of course, in the data, we cannot directly observe which consumer is which type, but there is a way to distinguish consumer types, or at least there are ways to estimate the composition of different types of consumers. So here I'm showing the model prediction by consumer type. So this one is marginal price type, and this one's average, and this one's confused. So looking at this marginal price type, we observe a bunching around 100. So this bunching is induced by the kinked budget set. And looking at the average price type, we see very smooth distribution around 100. And this is because the average price changes continuously or smoothly at the threshold. And lastly, looking at this confused type, so we see the striking bunching just below 100, but we see a small missingness. So which means that confused type consumers don't consume just a little bit above 100. So these are the differential predictions from these 3 types of consumers. So later in the estimation, we're going to try to estimate the composite of consumer types across these 3 different types. So now we move to estimation and identification, and probably I will go briefly estimation section and rather spend more on simulation part. So we have this utility function, alpha, lambda, gamma are the parameters to be estimated. And also we assume that, consumer is either one of these three types, but we don't know the shares. So we want to estimate the share of each consumer. And for estimation purpose, we rely on the observations around this 100. That is the masses below and above 100. So because by looking at this figure, the mass above 100 and below 100 are quite different depending on the type of consumers. And we're going to utilize these observed masses around 100 to identify the composition of consumer types. And then estimation will be done by simulated method moments. And here are the parameter estimates. So there are two implications. So first, much of consumers are actually average bias, which is in line with the previous finding in Ito 2014. And secondly, we calculate the price elasticity of demand, that is, how much the demand changes when electricity price increases by 1%. So it turns out to be 0.4, a negative 0.4. So this number is a little bit larger compared to the findings in the literature in developed countries as well as in developing countries. So as far as I know, I don't see like our previous studies in this Bhutan context, so we can't directly compare that, but so this is what we get so far. And then here I'm showing the model fit. That is how well my structural model can predict the consumption pattern. So these orange bars are model prediction, and these blue bars are like data. And overall, the model fit seems okay. So now probably I have 10 minutes or something like that.
If you can go over by actions 5.
Okay, good. Okay. So I'm going to talk about policy simulations for welfare analysis. So I'd like to analyze the impact of the free electricity policy. And also I'm going to think about the optimal pricing design and its welfare implications. And for consumer welfare, we use so-called Atkinson's type welfare criteria. So probably this might be a little bit new to many people. So here I calculate this consumer surplus at the individual level, and then I aggregate this consumer surplus with this a parameter R. So when this R is equal to 1, it's gonna be just the average or just summing up the consumer surplus across people, which is just the utilitarian welfare. But if we set smaller R, it implies inequality aversion. That is, we're going to think about some distributional implications in terms of consumer information. So the first analysis on the evaluation of the free electricity policy. So we basically compare the baseline as well as counterfactor. That is like the case with and without subsidy. So by with subsidy, I mean that it sets zero price for the first tier. And here are the results. So in this table, we show the per consumer and month level outcomes in terms of consumption, expenditure, surplus, as well as welfare for the case without subsidy and with subsidy. So starting from this consumption, we observe that the consumption increases by around 17.6%. So to be completely honest, this number seems a little bit large compared to the DID estimate that we obtained. So we still need to work more on this. But regardless, and about the expenditure, it decreased by 40 neutron per month. And the consumer surplus increased by 50 neutron per month per consumer. but which means that this consumer surplus increase is mostly coming from lower expansion. And then overall welfare change in the overall welfare tends to be negative, which means that this policy was not welfare improving overall. And then here I'm showing the heterogeneity of the policy effect depending on the consumption with the subsidy as well as consumer types. So looking at this panel, so we see that this y-axis is the change in consumption due to subsidy, and this x-axis is consumption without subsidy. So looking at this like marginal price type consumers who have correct understanding, if those consumers already consume more than 100, they don't respond to the policy change because that policy was only about the first year, which is the unit price below 100. But average price consumers also responds even if their consumption is above 100. So this is because those people will face lower average price because of the free electricity policy. And regarding the effects on consumer surplus, overall, those who consume more tend to be benefited. So this is because of the structure of the policy. That is, you can get free electricity up to 100. So then we're gonna think about some like alternative policy design. That is, let's say we're gonna fix the budget regarding this subsidy program from the government. So the question is how much we can improve the outcome. So here we simulate the optimal tariff schedule to maximize this utilitarian consumer surplus subject to the profit requirement. So this profit requirement is about at least the government to keep the same budget across different policy scenarios. And here's the result. So this red one is free electricity policy. That is the baseline case that we observe in reality. And this green one is optimal nonlinear pricing, which is much flatter than this like a red one. And also we have this optimal linear pricing, which is completely flat. So this suggests that the optimal pricing that maximizes utilitarian welfare is basically more flat. But this policy seems to have some distributional implications.
Can I ask you one question?
Sure.
Because you talked about these 2 or 3 types of households.
Yeah.
But given that the income in Bhutan has increased dramatically, even in rural area, where the income was very low when I was a little boy going to schools and so somehow I think the cost of electricity also is very, very low.
Yeah.
Because the price is very low. So my thinking was that people are indifferent. There are a group of people who don't care, like whether subsidy was given or not. They just close their eyes and consume, right? Irrespective, they don't really consider subsidy in their consumption basket because it's too small.
Yeah.
To their overall income and their consumptions. So where do they fall in these 3 categories of household achievement?
Yes. I think that's so like a rich households who don't care that much about the electricity expenditure because they are rich. I think that that kind of behavior should be captured by the price elasticity rather than by the types. Like if you're super rich, you don't care about that much, electricity expenditure. That means that you are price
Insensitive.
yeah.
Because, and also like, you don't consume limitless, right?
Right.
Because there's some needs, that's it. So And the income has really increased in Bhutan,
Yes, yes, yes.
in rural areas.
Mm.
So I was thinking that
So-
people are not very sensitive to these
Yes,
subsidies.
yes, yes.
Maybe like, poorer household, a little bit for them also, like, I think the subsidy of that is so small, they don't care.
Yes, yes, yes.
How big is this price relative
Yeah, it's-
to,
It's very small, I think less than $1, right, per unit.
Yeah.
but relative to the average
I
income?
think it,
3%.
3% of the average income.
Average expenditure.
Average.
Yes, as per.
It is still quite.
That's the household share of the expenditure, 3%.
Yeah, household, among household expenditure.
The share is only 3%.
Yeah, share 3%. Yeah. So we don't have a good measure of household income.
we'll talk later.
Oh, yeah, sure, yeah.
3% is based on the living standards, based on that.
Just because it's percentage of the average, not the high income.
If you need more time, please feel free to use it anyway. You can't understand it.
Okay. Okay, so let me conclude in maybe 5 minutes or something. In a few minutes. Okay, so then let me show you some welfare impacts. So compared to free electricity policy, this like a simulated optimal nonlinear pricing only changes consumption by 3 or 4%. And regarding utilitarian consumer surplus, the change is pretty limited. But one interesting thing is that if we consider like an inequality aversion in the consumer welfare measure, it actually has negative implication. So this is because it's like a green one. I mean, the unit price increases from red to green, but the second and third tier goes down. So which means that those who consume less will be hurt more. And then lastly, we simulate the optimal pricing that thinks about that incorporates such inequality aversion. And we actually, so this blue line shows the pricing, which we find that actually it predicts zero price in the first year. So which basically suggests that this free electricity policy was mostly justified from the perspective of distribution implications. Okay. So I already talked pretty much about everything. So but there's still some work that need to do. But probably let me stop right here, and I'm happy to take any questions as well as have some discussions. Thank you very much.
So is there any? There's no question from the. Do you have any questions?
I believe it was mentioned before, but my question was, for the consumers, how did you make sure that everybody was aware of the subsidy? Because maybe some consumers did not know and continued consuming as before. So maybe if you make sure that you take into account only the consumers that are aware of the policy, maybe the effects could be different.
I see. So I think so this policy was actually part of the promise made by the winning party in the election in 2013, right?
Yes, that's
2013. So that this like a subsidy program was part of the a promise made by this winning party. So in that sense, consumers are very well aware of of this new policy. So, of course, it's hard to know directly whether actually consumers acknowledge the policy or not. But still, I think it's reasonable to assume that consumers are well aware of this new policy.
and giving results, so we don't see some effect, and effective is negative right after the policy change. So perhaps that was a period when they were not 100% sure if they are really going to get a subsidy or not. So that's why, policy has no effect there. But after some time, they realize that maybe the bill is much more lower, so they confirm that. I think, yeah, after 3-4 months, they knew that subsidy was actually there.
I like Bill's explanation better on this. Actually.
There's mine is alternate.
Can I ask one question? Can I ask one?
Yeah, sure. There.
Yeah, so I think this has been quite a puzzle on this utility because it is never a non-linear pricing the most of the time, and then of course I think this policy is very important aspects to really look at the welfare. This is a very important economic problem that we need to tackle. So, what is your intake in this? Like, what is the optimal strategy that for example, looking at your studies, you are showing that like this free pricing was not very effective to the welfare. So, what is your kind of suggestion to the maybe policymakers? Like, what would be the kind of the stand to take when it comes to the utility? Because like given this situation, the people might have lots of this misperception, and it's very hard to understand the pricing scheme, right? That's why I think the behaviorally it's very hard to really juggle the people, because if it is linear, I think it's very easy.
Yeah.
Like we all understand in the consumer behavior that's very easy when it's linear.
Right.
But when it's a block pricing, it is very difficult, right? Then I think like if we really want to tackle this policy through the behavioral angles, right? What would be the optimal strategy, or what would be the optimal solution that we should really look into? What would be the kind of the lever that we should really pull to really design the policy? Because like I do lots of research in the like the experiments, like lab experiments, field experiments, where I really try to understand people's economic preferences. And then like if I had to design some kind of knowledge, because if like looking at here, like it is not really going to move the people. So what without studies? What would be your suggestion on that?
I see. Yeah, that's a very good question. So, and also tough question. So, there is like really a tension that like trade-off. So let's say, as you said, linear pricing is very simple. There is no confusion. But linear pricing basically means that, everyone faces the same unit price. But to address distribution concerns, or to offer like a subsidy for like low income people, well, this like a non-linear pricing is good, but it is associated with this perception issue. So yeah, so right now I don't have a good like a definitive answer or policy recommendation, which obviously I will be work on in the revision of this paper. But at least what I can say for now is that okay, there is trade-off, associated with linear versus non-linear. So yeah, that's a good question. Yeah, I work on that. Yeah, listening out.
Yeah, I think like somehow I think your work shows that, because when the things are linear, the guys are going to be hard very much, because those who are like this, when the users are going to be hard. I think you have shown that in the very part of the last part of the presentation that is there, right?
Yeah.
But I think I'm also like really trying to think on this, like because this block pricing and kind of things. And then it's very difficult for people to really react to that. Then government sometimes thinks like they want to come up with a water conservation, electricity conservation, and then, like when you want to bring this kind of things, it is very like difficult to really handle this kind of thing. So I was thinking like, what could be the solution?
Yes.
How does it?
If my guess is correct, I think this is coming, your question is coming from the very complicated electricity tariff in Nepal. They have a fixed cost.
Okay.
Fixed cost also depends on how much you consume.
It depends how much you consume.
That's right, yeah.
You mean like the capacity?
Yeah, capacity, yeah. And capacity, and also like there are certain threshold, like if you consume more than your fixed cost. Looks like linear pricing,
Yeah,
but it's a fixed cost.
Yes. Just out of curiosity, why do you always linear versus non-linear pricing? To me, it looks more like this a single pricing versus a block pricing, which does not necessarily have to imply linear and non-linearity. Just out of curiosity, why is it non-linear?
When you have linear
What do you call it non-linear pricing? It's a simple block pricing. Looks like to me.
block pricing.
So I got some confusion when I read the title. Does it mean like non-linear? I thought is this some non-linear series, non-linearity is non
Yes.
and the pricing when I see it looks to me this.
So actually, this nonlinear pricing comes from the literature on price discrimination in economic theory. When we say linear price, it basically means that like a unit price is fixed.
Yeah,
like a
it's
unit
single
price.
pricing.
Yeah, single pricing. And other than that situation, we say nonlinear pricing in the price discrimination literature. So that's it.
I'm not an expert on that field, so I don't know. He's just curious.
Yeah, you're right. But I understand your point. Yeah, this, like for example, this budget set is still linear. I mean,
Yeah.
this budget set is still linear.
It's king. The king.
Yeah, king, but linear.
Basically.
Yeah,
Yeah.
I see.
But one. Can you go back to the old versus new pricing schemes? I think it's in your-
This one?
Yes.
Yeah.
So if I looked at the difference between the left-hand side, so the left-hand side, panel A
Yeah.
is price schedule before subsidy.
Yeah.
And panel B is price schedule after subsidy.
Yeah.
When you look at the price schedule, when you compare between the panel A and B, after the introduction of this subsidy, you look at some pricing changes also being applied into the different subgroups, right?
Right. Yeah.
How does that take them into account in the analysis?
So
Because there will be some behavioral changes in those consumers as well. So the drop in the first few months after that, the drop of electricity demand in your DIT analysis could actually also come out of the results of that price changes or price increases in the higher section.
I see.
But-
Our consumers also experience price change
Yeah.
before and after
So
this introduction.
Are they controlled? Are those kind of things controlled? Regulations.
That's actually a bit hard to directly control in deep analysis. Again,
But then again, you cannot really say that this is a pure definitive because there is some other mechanism is at play, like
Right.
changing the demand. So I'm not sure. You might want
I see.
this thing.
Yeah, two things got changed at the same time.
Yeah.
I mean, the price got changed and the policy got changed. So, yeah, I think it is not very.
So
It is hard
to
for you to decide these factors.
Right. So actually, that partially motivates why we take a model-based analysis later. That is, once we introduce economic model, we can take into account like the change in pricing schedule for our consumers before and after. So like order pricing schedule is an input into our structural economic model, and we can take into account that change.
So if I'm not mistaken, in this simulation analysis, you basically conclude that this zero price in the urban tariff policy has negative implication on welfare in general.
Right.
Now that negative implication could that also be an effect of this increase in prices for the higher group of consumers?
Actually, no, because in our simulation design, so we compare two situations. One situation is, okay, so I fix the pricing schedule
Yeah.
with like a positive first tier price.
Yes,
And then-
penalty, right?
Yeah, and also we compare another situation in which I only set the first tier price 0. So in that sense, across these two situations, the unit price in the second tier and third tier are fixed. The only difference is the price in the first tier.
Okay, so you're not specifically comparing penalty and being.
Yeah, exactly.
Sure.
So that's why we are relying on simulation analysis to make a good comparison, like apple to apple comparison.
Yeah, I agree. We don't know. Like, I'm just surprised that that's the government can provide free electricity because like in Laos, the like see those kind of policies are that's kind of interesting to me. And also like in the DIB graph, it seems like there might have been like a bit of an anticipation effect before.
Anticipation effect.
Yeah.
Mm.
Right. Like that one. I mean, so maybe the policy was announced like ahead of time and supporting the promise of like.
Yeah.
Yes, the policy wasn't, I don't know exactly the exact timing.
The campaign started sometime in 2012.
2012.
Actually, that's interesting. You just mentioned the policy. Is it like the related to the campaign like tariff separation like for this policy? That's why we might have seen that little dip before. That's very interesting.
So we use this like consumption in 2012 as a matching variable. So the reason was that, maybe I should change better, right? The policy was announced in 2013. I mean, in 2012, at least people are not so aware of this like a new policy. So in that sense, I use this 2012 just to make a matching comparison. And then I use the 2013 until October to show some like placebo effect. So we see some like a significant effect just one in here, but overall this like a treatment effect or placebo effect is pretty close to 0. So in that sense, we are not super worried about like this like anticipation.
Okay, I think we don't have any questions from online, but Chris, we don't get a question. So anyway, so let's conclude here and thank you so much.
Thank you very much.
How many people?